Dear students, welcome to my classroom. Today we are going to start a new chapter which is very important in our 10th class syllabus, and the chapter is similar triangles. So it is very useful to find the heights and distances of unknown objects using principles of similarity of triangles. Students, so here I am presenting a picture, and I think all of you know that it is very famous and world renowned, and that is symbol of love, and it is Taj Mahal. So in this figure 1, so we see the picture of Taj Mahal, whose height is 4 centimeters and breadth is 6 centimeters. So as it is looking very small, I want to increase its size. So I am taking the height twice the height of figure 1 and breadth, keeping the breadth same, like this. So in this figure 2, we have height is 8 centimeters and breadth is 6 centimeters. So do you think the figure 1 is similar to figure 2? I don't think so. So now I am increasing the breadth and keeping the height same, like this. In this picture, I doubled the breadth and kept the height same. So is it similar to first one? So here also this figure is not similar to first figure. Pictures are same, but they are not similar. So now I am doubling both height and breadth in this figure 4, like this. Now the height is 8 centimeter, breadth is 12 centimeters, which are twice the measurements of first figure. So in these 4 figures, which two are similar? What can you notice? So we can notice that the figure 1 and figure 4 are similar. So these two are similar pictures. And in these two pictures, the ratio of corresponding heights as well as ratio of corresponding breadths is same, and this ratio is called scale factor. The ratio of corresponding heights or corresponding breadths is called scale factor, and in these two figures, the scale factor to figure 4 to figure 1 is 8:4 or 12:6, which is equal to 2. So the scale factor in these pictures is 2. But in geometry, what is the similarity of figures? So the two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or in proportion. Okay, two polygons of the same number of sides are similar if the corresponding angles are equal and the ratio of corresponding sides is same. So, and we notice that all regular polygons having the same number of sides are always similar, like all squares are similar and all equilateral triangles are similar, like this. And also we can say that all circles are similar and the circles with same radius are congruent. So here these circles are similar and these two circles are congruent circles. Okay, so I think you know that what is congruent figures. Two figures, if two figures are in same in size as well as in shape, then the figures are said to be congruent figures. So let us do an activity to find the relationship between the angles as well as sides in similar figures. So place a table under a bulb which is fitted to ceiling, like this, and keep a cardboard of shape quadrilateral whose vertices are A, B, C, D under the bulb like this. Here A, B, C, D is a cardboard which is in the shape of a quadrilateral. And when the bulb is lighted, the shade of this cardboard falls on this table like this. And now mark the outline of this shade, and we can notice that this shade is also in the shape of quadrilateral, and denote the vertices of this shade by A1, B1, C1, D1. Now find the angles A, B, C, D as well as A1, B1, C1, D1. And we can notice that the angle A is equal to corresponding angle A1, and angle B is equal to angle B1, angle C is equal to angle C1, as well as angle D is equal to angle D1. So we can say that all the corresponding angles in the similar figures are equal. Here, the quadrilateral A1, B1, C1, D1 is the enlargement or magnification of the quadrilateral ABCD. We know that the shade of an object, the shade of an object is similar to the object. So in these two figures, that is in these two similar figures, all the corresponding angles are equal. And measuring the sides of these two quadrilaterals and by finding the ratio of corresponding sides, we can notice that AB by A1 B1 is equal to BC by B1 C1 is equal to CD by C1 D1 is equal to AD by A1 D1. That is, the all the corresponding sides are in same ratio. That is, we can say that they are in proportion. So students, we can say that in similar figures or in similar polygons, all the corresponding angles are equal as well as all the corresponding sides are in same ratio. Now, let us do an exercise which is given under the title "Do this in textbook." So first one is here, fill in the blanks with similar or not similar. Just we have to fill the blanks with similar or not similar, which is suitable. The first one is given that all squares are dash. So we know that squares are regular polygon. So we can say that all squares are similar. Also, all equilateral triangles are similar because they are also regular polygons. All isosceles triangles are. So in isosceles triangles, in two isosceles triangles, the ratio of equal sides are equal, but ratio of corresponding equal sides are equal, but the ratio of third side may be differ. So all isosceles triangles are not similar. Two polygons with the same number of sides are dash if their corresponding angles are equal and corresponding sides are equal. So we can easily say that two polygons with the same number of sides are similar if their corresponding angles are equal and corresponding sides are equal. Reduced and enlarged photographs of an object are similar because the photographs reduced or enlarged are similar to each other. Rhombus and squares are dashed to each other. What do you think? So they are similar or not? So we can say that in rhombus and squares, ratio of corresponding sides may be equal, but ratio of corresponding the corresponding angles are not equal because in squares all angles are equal to 90 degrees, but in rhombus they may be not equal to 90 degrees. So rhombus and squares are not similar to each other. So, and in second one, it's given that write true or false for the following statements. The first one, any two similar figures are congruent. So we know that two similar figures are congruent if and only if the corresponding sides also equal. So two similar figures are not congruent unless the corresponding sides and corresponding angles are equal. So the statement is false. Any two congruent figures are similar. So in congruent figures, all the corresponding sides and all the corresponding angles are equal, so that any two congruent figures are similar. So the statement is true. So students, so any two congruent figures are similar, but its converse is not true. That is false. Okay. So two polygons are similar if their corresponding angles are equal. So it is also false statement. And give two different examples of pair of similar figures, not similar figures. So for similar figures, any two circles are similar and any two squares are similar. And non-similar figures, rectangle and parallelogram are not similar because the corresponding angles may be differ with each other. And right angle triangle and equilateral triangles are also non-similar figures, because in right angle triangle we know that one angle is 90 degree, and in equilateral triangle all angles are equal to 60 degrees. So that is corresponding angles are not equal, so that the equilateral triangle and right angle triangles are non-similar figures. Okay, so let us discuss the similarity of triangles. So two triangles are similar if corresponding angles are equal and corresponding sides are in the same ratio. That is, they are in proportion. So in triangle ABC and in triangle DEF, angle A equal to angle D, angle B is equal to angle E, angle C is equal to angle F, and AB by DE is equal to BC by EF, and AC by DF is equal to some K, then only the triangle ABC is similar to triangle DEF. That is, in two triangles, if corresponding angles are equal and the ratio of corresponding sides is same, then the two triangles are similar. So symbolically, then we write as triangle ABC similar to triangle DF. This is the symbol of similarity. Okay, and if here we know that the K is called scale factor. Already we discussed earlier. K is scale factor, and if K less than 1, then we get reduced figure like this. Here ABC and triangle DF. Triangle ABC and triangle DF are similar triangles, and AB by DE less than 1. So then the figure is reduced to small size. Okay. And if K is equal to 1, then we get congruent figure like this. Here ABC and triangle DF are congruent. And if K greater than 1, then we get enlarged figure like this. Here a triangle DF is enlarged figure of triangle ABC. So if the scale factor is less than 1, we get reduced figure. And if the scale factor is equal to 1, then we get congruent figure. If the scale factor is greater than 1, then we get enlarged figure. Okay, so now do an activity. Take a ruled paper and draw a triangle ABC on this paper like this, and take 2 points P and Q on any line where the line meets the triangle like this. Here P and Q are in this line and as well as on the triangle. Now measure the lengths AP, PB, AQ and QC. AP, PB, AQ and QC. Now find the ratios AP by PB and AQ by QC. Again, change these points to another line like this. Here also measure the lengths AP, PB, AQ, QC, and also find the ratios between AP and PB and AQ and QC. So do this activity again and again for 2 more lines. Now we can notice that AP by PB and AQ by QC are equal. So in triangle ABC, and here we can notice we know that all the lines are parallel. So in triangle ABC, if PQ parallel to BC, then AP by PB is equal to AQ by QC. This is known as basic proportionality theorem, and it is named after the mathematician Thales. So it is also called as Thales theorem. So let's prove the basic proportionality theorem. And the theorem is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. So here we have a triangle ABC and draw a line DE parallel to BC. Now the given is in triangle ABC, DE parallel to BC, which intersects AB and AC at D and E respectively. And now the required to prove is the ratio of AD is to DB is equal to AE is to EC. That is AD by DB is equal to AE by EC. So to prove this, we have to make a construction here. Join B, E and C comma D like this, and then draw DM perpendicular to AC and EN perpendicular to AB like this. So let's prove the theorem. So take the area of triangle ADE. So in this triangle, if we take AD as the base, then corresponding height is EN. And we know that the area of a triangle is half into base into height. So if we take AD as base, the height is EN, then the area of triangle AD is half into base into height. That is half into base AD and into corresponding height is EN. And the triangle area of triangle BDE is the base of the triangle BDE is BD and the corresponding height is EN. So the area of triangle BDE is half into base DB into height EN. Now the area of triangle ADE by triangle BDE. Take the area of triangle ADE by area of triangle BDE. So substitute the values of area of triangle ADE and area of triangle BDE. We know that area of triangle ADE is half into AD into EN and area of triangle BDE is half into DB into EN. And we can cancel halves and EN in numerator and denominator like this. And now we remains with AD by DB. Therefore, area of triangle ADE by area of triangle BDE is AD by DB. Take it as equation 1. And if we take AE as the base and DM as the corresponding height, then the area of triangle ADE is half into base AE and corresponding height DM. So half into AE into DM. And area of triangle CDE. So here we have triangle CDE. So for the triangle CDE, C is the base and the corresponding height is DM. So area of triangle CDE is half into base EC into height DM. Again, find the ratio of area of triangle ADE and area of triangle CDE. We have half into AE into DM by half into EC into DM. So here also we can cancel halves and DM in numerator and denominator. And we remains with AE by EC. So take it as equation 2. And students, here in this figure, we can notice that DE parallel to BC and triangle BDE and triangle CDE. Triangle BDE and triangle CDE are on the same base DE, and they are between the parallel lines DE and BC. And we know that two triangles between the same parallel lines and with the same base are equal in area. So that area of triangle BDE is equal to area of triangle CDE. Take it as equation 3. Now students, observe this equation 1 and equation 2 and equation 3. Here we have area of triangle BDE is equal to area of triangle CDE. So in equation 1 and equation 2, we have area of triangle BDE, area of triangle CDE in denominators. Remaining all are same. So here we can equate the equation 1 and equation 2. So from these equations, we can write AD by DB is equal to AE by AC, which we have to prove here. So hence the theorem is proved. So students, observe the basic proportionality theorem again. If a line in a triangle, if a line is drawn parallel to one side, then it divides the remaining two sides in the same ratio. That is the theme of basic proportionality theorem. So let us see the another forms of this theorem. So if D is parallel to BC in triangle ABC, we have AD by DB is equal to AE by EC. Now add 1 to both sides of this equation. So we get AD by DB plus 1 is equal to AE by EC plus 1. So by simplifying this, we get AD plus DB by DB is equal to AE plus EC by EC. So we know that AD plus DB is equal to AB as well as AE plus EC is equal to AC. So that we can write it as AB by DB is equal to AC by EC. So in this figure, observe that AB by DB is equal to AC by EC. Similarly, we can write also that AD by AB is equal to AE by AC. These two are also the another forms of basic proportionality theorem. We use these forms whenever we required in problems. And let us see the converse of basic proportionality theorem. So the converse of basic proportionality theorem is if a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side, like this. That is, if DE divides such that AD by DB is equal to AE by EC, then DE parallel to BC. This is the converse of basic proportionality theorem. And in next class, we are going to solve some problems based on basic proportionality theorem and its converse. Okay, students, that's all for today. So in next class, we are going to solve the problems in exercise. And until then, bye. See you in next class.